Welcome to my YouTube channel. Today we'll be talking about polynomials. Now, the general representation of a real polynomial f of x in a variable x of degree n is given by f of x equals to aₙxⁿ plus an minus 1 xn minus 1 plus plus a1 x plus a0. So this is how this is the way the general form of a polynomial is written. All these an minus 1, they are all constants. They could be 0, they could be 1, they could be 2, they could be anything. So they are real numbers. So definition is this your an. Remember, this is degree n. So the an, that is the coefficient of this s raised to the power of n, is called the leading coefficient. The n is the degree of the polynomial. So if n is 1, you get degree 1. If it is 2, degree 2. If it's 3, degree 3, like that. Then a0 is the one that doesn't have the s. It's called the constant term. It is also very, very important, in this lecture, that when the different names we give a polynomial when n is 0. When n is 0, if n is 0, we call it a constant polynomial. When n is 1, we call it linear. In that case, we get a1x plus a0. When n is 2, we call it quadratic. Then when n is 3, we call it polynomial. S3, a2, s2 plus a3, a1, s1 plus a0. So this is cubic, this is quadratic, this is linear, and this is constant. So that is it. So moving on, yes, we'll be looking at the division of a polynomial. This is also very, very important. It's important you know how to perform the division operation. A polynomial f of s can be divided by another polynomial, provided that the degree of g of x is not greater than the degree of f of s. So you know what they mean by degree. So a polynomial with lower degree can divide a polynomial of a higher degree. So like the quadratic can divide the cubic, the linear can divide the cubic, but you can't use the quadratic to divide the cubic. So that is what they are trying to say here. So g of s is called the divisor. So the one you are using to divide is called the divisor, and g of s is not 0. So when you are dividing, if you have f over x over g of x, if the g of x, which is the divisor, is 0, I'm saying f of x over g of x. So if the denominator is 0, you get undefined. So this division can't work. So you have to ensure the denominator is not 0. Now your f of x can be written as g of s times q of s plus r of x. So your g of s is the divisor, your r of s is the quotient. That is the answer you get when you use g of s to divide, and r of s is the remainder. In normal mathematics, if I do 5 divided by 2, I will get 2 times remainder. Maybe you can say plus plus 1 over 2. Plus 1 over 2. 5 can be written as 2 times 2 plus 1. So this 2 here is the divisor. The number of times that 2 goes into 5 is 2. That one is called the quotient, and this one is called the remainder. So that is what they are just trying to do here. So your answer could be when you use g of x. Let me write that. If you use g of x to divide r of s, you will get q of x plus r of x divided by g of x. So this one is the remainder, then you get g of x, just like the way you have 2 plus 1 over 2. So you can't divide this because the degree of r of x will actually be lower than that of g of x, so you can't do this division again. So that is why if you see this one says you can only divide a polynomial if the degree of the top is greater than, that is the degree of f of x is greater than the degree of g of s. So if this one is less than, you can't perform, even if, I think you can still do it if it is equal to it, but then when it is less than, you can't perform division again. So you just leave it like that. The r of s, the one at the top, just becomes the remainder automatically. So let's look at some examples. Yes, the division. So we are asked to divide the following. So we are going to use the log division method to compute the solution of all these problems. So you can pause the video, try to attempt the questions, and then when you are done, you can play it and verify your answer if you are right. So solution, starting with the first one, we have we have s plus 2, then we have s cubed plus 3s squared minus s plus 1. So s, if you do division now, s into s squared, s cubed, you get s squared. You use this answer you get to times these two terms, you get s squared plus 2s squared. You subtract it, you get s squared. You can drop one term, it's okay. Then s into s squared, you get plus s. S times this, you get s squared minus 2 plus 2x. Now you subtract it, that will give you minus 3x. You can drop the 1 plus 1. S into that, you get minus 3. Minus 3 times that, you get minus 3x. Minus 3x minus 6. So what do you do now? You minus again. 1 minus 6 will give you 7. This and this will give you 0. So 7 is the remainder. So at the end of the day, our conclusion is s cubed plus 3s squared minus s plus 1 divided by s squared plus 2 is equals to s squared plus s minus 3 plus the remainder is 7 over s plus 2. So you could see that the degree of the numerator is lower than that of the denominator here, so you can't further divide. So this is your final answer. Let's go to question 2. So in question 2 is a bit trickish, but then let's just do it together. F cubed minus 1. So let's divide. 7x divide 5s cubed, you get 5 over 7s squared. 5 over 7s squared times this will give you 5s cubed. Then this times 1, you get the same thing, that is plus 5 over 7s squared. You subtract it. Okay, subtracting this, we cancel this, so you have there is no s square at the top here, so it's only this 5 over 7 s squared that is s squared, so it will just be minus 5 over 7 s squared. You could add the minus 1 that is at the top back. So the 7s, we divide this, so that will be minus 5 over 7s squared divided by 7s. So if you do times now, that will be 1 over 7s. This will cancel, the s will cancel s, 1s will be left. 7 times 7, that will give you 49. So at the end of the day, we have minus 5x over 49. So this will times this, you get, if this times this, 7 will cancel the 49 to remain 17. So you get 5 over 7s squared. So this times 1 will give you minus 5x over 49. You subtract again, the first term will stroke out themselves. There is no s at the top, so it's only this one you have. Minus times minus will give you plus, so that is 5x over 49. Then you minus this one. You do division again. If you divide that, 5x over 49 divided by 7x, you get 5 over 7 times 49, which is 300, and you get 343. So that is what we get. So that will be plus 343, plus 5 so you get plus 5 over 343. So this with times this, that will give you 5x over 49 plus 5 over 343. So you minus again, you will now get minus 1 minus 5 over 349. That will give you minus 348. You can use your calculator for that. 348 divided by 343. Yes, so that is what you will get. So at the end of the day, we are done. So s cubed, 5s cubed minus 1 over 7s minus 1 will be equals to 5 over 7s squared minus 5x over 49 plus 5 over 343 minus 348 over 343. So this is the remainder, so divided by 7s plus 1. So this is the quotient, this is the remainder. Let's go to the third question. So the third question is 5s cubed minus plus 14s squared minus 6s minus 8. So we are dividing it by 2s squared minus s minus 3. So when 2s squared divide this, you will get 5 over 2s. 5 over 2s times this will give you 5s cubed again. 5 over 2s times s will give you minus 5 over 2s squared. 5 over 2 times minus 3 gets minus 15x over 3. Now you minus. When you minus this, you get, this side gives you 0, this one become plus. If you add that up, you get 33 over 2s squared. So minus times minus will still give you plus, so you get plus 3 over 2x, then minus 8. So you do your division again. If 2s squared divide 33 over 2s squared, you will have 33 over 4. 33 over 4 times this will give you 33 over 4s squared. So this times 1, x will give you 33 over 4x. 33 over 4 times 3, you get minus 99 over 4. Now you subtract it again, so that will give you 0 on this part. 3 over 2x minus 33 over 4x will give you 39x over 4, then plus 67 over 4. So the thing, are we done? Is this the remainder? So look at it. The degree of what you are using to divide is 2, but the degree of this one is 1. This can't divide this anymore, so this is where you stop. So we are done. Just write 5s cubed plus 14s squared minus 6s minus 8 when you divide it by 2x squared minus x minus 3, the answer is 5 over 2x plus 33 over 4 plus the remainder is 39x over 4 plus 67 over 4. This is the remainder. So the remainder divided by 2x squared minus x minus 3. So this is the remainder. It can also be written as 14x squared minus 6x minus 8 is equals to 5 over 2x plus 33 over 4 times what you used to divide plus the remainder. So anyone you write, you are correct. So the remainder theorem, this theorem is very important in this course. It is important you understand the remainder theorem. So let's continue. If a polynomial f of x of degree that is greater than 1, so that is n is either 1 and greater, it can be 2, it can be 1, it can be 2, it can be 3, all the way to anything, is divided by ax plus b. So look at it very well. You can use this theorem, this remainder theorem, only when you are dividing a polynomial. You are dividing a polynomial by a linear equation, by a linear expression, that is ax plus b. If it is not a linear expression, if you are using another expression, if you are dividing by quadratic, you can't use this remainder theorem. You can't use this particular theorem. Okay, so if you are using this theorem, then the remainder, if the question asks you what is the remainder, you don't need to use the long division method that I solved before in the first 3 videos, in the first 3 examples. You don't need to use that question if it is a linear expression. But if it is quadratic, if it is a quadratic expression, you will need to use the long division method. But if it is linear, you don't need to. This is a theorem that you can always use. It is at your disposal. So how do you do that? You have f of x, right? F of x will be given to you to be something. Now we have a plus b to be what I'm using to divide my f of x. Just equate this to 0, get the value of x, you get minus b over a. So this minus b over a, put it inside the function, substitute it inside. Whatever you get is your remainder. Whatever you get is your remainder. Do you understand? That is the remainder theorem. That is what it's saying. But it is possible that you get your remainder to be 0. If you get your remainder to be 0, it means that if you get your remainder to be 0, it means that the ax plus b, this ax plus b now is a factor of f of x. Is a factor, meaning it can divide f of x. It's just like normal mathematics, that if I have 4 over 2, I will get 2. There is no remainder. If I have 5 over 2, I get 2 times 2 plus 1. There is a remainder, which means that 2 is not a factor of 5. But if there is no remainder, it means that 2 is a factor of 4. Okay, so we are asked to find the remainder of these following problems. So to solve it, you do 2s minus 1 equals 0. What is s? S is equals to 1 over 2. So you substitute that into your f of x. So that will be 1 over 2 raised to the power of 3 minus 3 times 1 over 2 raised to the power of 2 plus 1 over 2 minus 5. So if you compute this, 1 over 8 minus 1 over 2 is 4. So that is 3 over 4 plus 1 over 2 minus 5. So if you use your calculator, so that is the remainder. That is the remainder. So the next question, s plus 1 equals 0. S is equals to minus 1. So f of minus 1 becomes 6 times minus 1 raised to the power of 3 plus 2 times minus 1 raised to the power of 2 minus 1. So this becomes minus 6 times 2 minus 1. That is minus 7 plus 2. That is minus 5. So this is your remainder. So that is the how to use the remainder theorem. Yes, the factor theorem is if you are using a plus b to divide your polynomial, just like the remainder theorem, if you substitute the value of x into the function and it gives you 0, it shows that ax plus b is a factor. Okay, so we are asked to do this following. So to solve this, solution number one, just equate it to 0. S is equal to 2. So f of 2 is what? 2 raised to the power of 4 minus 15 times 2 raised to the power of 2 plus 10 times 2 plus 24. So that is 16 minus 60 plus 20 plus 24. So what will that give you? So we get 0. Then number 2, we have 2x minus 3 equals 0. S is equals to 3 over 2. If we insert that 3 over 2, we get 3 over 2 raised to the power of, that is 2 times 3 raised to the power of 3 minus 5, 3 over 2 raised to the power of 2 minus 12, 3 over 2 raised to the power of 2. Okay, there's no raised. Is it 12? Sorry, 21. Then plus 36. So this gives you 2 into 27 over 8 minus 5 into 9 over 4 minus 21 into 3 over 2 plus 36. So this is 27 over 4 minus 45 over 4 minus 63 over 2 plus 36. So if you add this up, it will give you 0. So that is it. It's a factor since it gives 0. So thank you. Make sure you subscribe. See you in the next video.